Welcome back to The Explainer. Today, we have an absolutely fantastic topic lined up for you. We're going to unpack the very foundation of how we measure, observe, and interact with the physical world around us, and perhaps more importantly, how we do it safely. Honestly, whether you're a seasoned researcher or you just love figuring out how things tick, getting a solid grip on these fundamental principles is absolutely essential.
So, quick question for you. Why is it dangerous to taste unknown substances during science activities? Now, I know it sounds like a no-brainer, but this question gets right to the heart of the high stakes involved in scientific inquiry. Our world is full of incredible things to discover, but without the right boundaries and tools, discovery can very quickly turn into a serious hazard. Keep that question in the back of your mind because we're going to answer it thoroughly today.
All right, here's our roadmap for this explainer. First, we'll meet your science toolkit. Second, we're going to look at the power of measurement. Third, we'll cover those essential science safety protocols. And finally, we'll see exactly how these tools operate out in the real world. Okay, let's dive into this.
Starting us off with Section 1, Meet Your Science Toolkit, the essential tools for investigation.
Think back for a second to the very first time you tried to figure out how something in the world actually worked. To go beyond just taking a wild guess, you needed instruments. Science tools are fundamentally defined as instruments that help learners observe, measure, record, and investigate accurately. They're basically our necessary bridge to understanding reality. Without these instruments, we're really just relying on our completely flawed human senses. These tools allow us to capture hard data, ensuring that when we look into a phenomenon, we're recording what's actually happening, not just what we kind of think is happening.
Interestingly, the standard tools found in foundational science curriculums, like the core elements of the Basic Force Science curriculum, are things you probably recognize. We've got the thermometer, a simple ruler, measuring cylinders, a hand lens, magnets, a balance, a clock, and some basic containers. This is your everyday arsenal, and every single one of these items exists to extend human capability. They let us interact with our physical environment in a highly precise, standardized way.
Moving right along to Section 2, the power of measurement and getting accurate results. Now, it's one thing to have a box full of shiny tools, but it's entirely another to know exactly what they are actually designed to achieve, and this brilliantly illustrates that point. Every tool is uniquely paired with a very specific function. A ruler maps directly to length, a thermometer, that captures temperature. A hand lens brings all those tiny details of small objects into crystal clear focus. A measuring cylinder handles liquids and volume, while a balance is used to figure out mass. Notice how there is zero overlap in their primary jobs. A balance is never going to tell you the temperature, right? Every instrument has a distinct, specialized scientific job. Which brings us to a fundamental, unbreakable rule of science. Using the correct tool helps learners get accurate results. Honestly, if you use the wrong tool, your investigation is dead in the water before it even begins. Just imagine trying to measure the volume of a liquid with a wooden ruler. It simply doesn't work. Using tools carefully and correctly is literally the only way to avoid wrong results and make sure your data actually means something.
Let's ground this in some practical, everyday examples. Step 1. You might use a ruler to measure the exact length of a pencil sitting on your desk. Step 2. You take a thermometer to measure the temperature of a room or maybe a glass of water. Step 3. You grab a hand lens to observe the intricate little veins of a leaf, making those tiny details large enough to see clearly. And here's the cool part. These micro-level classroom steps are the exact same processes that build the foundation for massive world-changing scientific discoveries.
All right, let's transition to Section 3, Essential Science Safety Protocols, Protecting the Investigator. Having all the right tools is fantastic, but if you aren't protecting the person using them, the whole operation falls apart. Safety isn't just a list of boring rules designed to ruin your fun. It is the essential armor for any investigator. That's exactly why the source material bluntly states safety must always come first. Because while tools definitely help you investigate better, that investigation instantly stops the second an accident happens. This is the absolute bedrock of any practical learning environment. So here are the golden safety rules you absolutely need to know. Number 1, listen to instructions. Number 2, handle tools carefully to prevent accidents and damage. Number 3, do not taste unknown substances. Keep your working area clean. And finally, report any accidents immediately. Now, notice how this answers the hook from the very beginning of our explainer. Why is it dangerous to taste unknown substances? Because without adult guidance and a crystal clear understanding of chemical properties, tasting, smelling, or even touching unknown things can lead to severe harm. These safety rules literally eliminate that risk.
To put it as simply as possible, behavioral expectations are key here. During a practical lesson, do not run, do not push, and never misuse the tools.
It can be super tempting to play around with the equipment, but treating the workspace with actual respect is exactly what separates a chaotic room from a true functioning scientific laboratory.
Let's wrap things up with Section 4, Tools in the Real World, taking this from the classroom all the way to a career.
We're going to zoom out now and see how these basic principles scale all the way up into the massive realm of human industry. So, the crucial point is this. The basic thermometer or ruler you see in a middle school classroom, it operates on the exact same scientific principles as the highly specialized tools used by professionals. A nurse's medical thermometer or a master carpenter's measuring tape are really just advanced versions of what we use to measure a pencil or check a cup of water. The underlying science is completely identical.
And you can see how this builds across the entire global workforce every single day. Nurses absolutely rely on thermometers to check patient health. Carpenters depend on measuring tapes for structural accuracy, otherwise a building might fall down. Traders use weighing scales to ensure fair commerce. Farmers rely on rain gauges to track weather patterns so their crops can survive. Every single one of these professions depends entirely on accurate measurement and the correct use of standardized tools. And because of that intense reliance, good scientists, engineers, and laboratory workers universally respect their tools and follow safety rules. It really doesn't matter if you're a 10-year-old student doing a baking soda volcano or a senior engineer at a global firm. That respect for the instrument and the strict adherence to safety protocols remains a constant requirement throughout your entire life.
So, let's consolidate what we've learned today. Ultimately, tools aid our measurement and observation, completely extending our natural abilities. But to use them, safety must always come first to prevent accidents. When used safely, accurate measurement dramatically improves our investigations, provided we remember the golden rule. Every single tool has a specific, correct purpose. You absolutely have to match the right tool to the right job. I want to leave you with this final thought to ponder. Which science tool do you personally find most useful? The next time you're in your kitchen, your garage, or just sitting at your desk, take a look around. You are literally surrounded by instruments of measurement and observation. Think about how they function and how those simple, everyday tools connect you to the broader world of science and discovery. Thanks for joining me on this explainer, and as always, stay curious.